Okay, welcome back to symbolic links. Symbolic links are also called soft links or symlinks, have you probably seen. It's a pointer to another file or directory which we call the target. It is useful for more than one reason. Could be useful for ease, because you don't have to write a long path each time you change to a directory. Like, for instance, your project directory. Then instead of writing a very long line, you just write the one word that maybe you have given it, say my project here or something. Or another thing is that you can also use it to avoid changing hard links that are within other programs or scripts. And that is very useful because maybe you're installing a program that assumes a library that it needs and is looking for is called something like deepcoolness.a. But when you download it, this library is called deepcoolness.2.0.a. And when a new version comes, it changes also again to maybe 3.0.a or 3.1.a or something like this. And then instead of renaming the library, or going in and updating all the many instances that there might be in this program and others, then you can just update the symlink. And of course, also it could be in another directory than where it expects to find it. Then you don't need to move it. You can just create a symlink to it where it is. So then the program sees it where it expects it to be and named as it expects it to be. But it will just be a symlink and it follows that. So that is another very good reason for using symbolic links. So symbolic links are also called soft links. So is there something called a hard link? And what is that? Well, hard links are also shortcuts to files, but not to directories. Soft links can also be shortcuts to directories, while hard links can only be to files. It cannot be created for a file in a different file system, so when it's a hard link. So the syntax for a soft link or a symbolic link is you say ln link -s, and then the path or the name, the real folder or library or path to it, and then what you want to name the link. If it's a hard link, then you just name the source ln link again, and then source file and linked file. To verify if it's a soft or hard link, you can run ls -l and the source and the link. So some examples here, and you can type along to most of them. Go to this directory here that I have also been using for redirection and environment variables under exercises, and whatever directory you put it in. There will be some examples that we can use here now to create these links here. So let's first try and make a hard link. And you can either use one of the files or directories in exercises here, or you can create a file to play with. So I am going to create a test file, just to have something to play with. And I'm just going to copy this here. Copy. And paste it. So I am redirecting the output of echo, this is my test file, to the file test file. And we will see that indeed it has this content. Now I'm going to create a hard link to this file here. And what I'm going to do is say ln, and then I will take test file, my target, and then I will say link file, because I'm going to name it link file. This linked file here. as you can see here. Yeah, source file, link file, yes. So I now have two files. I have test file that I created, and then I have link file, which is a hard link to this file, test file. And I will try do like this: ls minus li test file and link file. And what minus li is, L is just giving the long ls, so the much information output, and the I is telling me the inode. And you can see here the inode is the same. It's different than what I have here in the example, though not a lot, but it is because it's well, the path is different and things like this. But what is important is that both those two has the same inode. An inode or an index node is a concept that you have in Linux or Unix. And every object in a file system is represented by an inode. So it's a data structure that stores basic info about files and directories and other file system objects. And if you want more information, I have put in a link to a place where you can read more about inodes. But as you saw, these two are indeed the same file. So let's then try and create a symbolic link to our directory. And I am going to create one here. Just going to be clear to the top of the page. So I'm going to say ln minus s, and then I'm going to give my path to my home directory. So home bsoe, and then the link to this directory here, which is intermediate Linux exercises, redirects and link, and that is the path to this directory here. And then I am going to put that in my home directory so I can easily and fast go to this directory. Not inventive, I'm calling it exile. And now I could say pwd, so I can see this is indeed where I am. And then if I am going to do, say, ls minus l, and then my home directory, home, stop in it. But what matters is that up here is exa, and the environment link here. So that is what matters here, and it's indeed there. Okay. So we have that, and as you saw, it pointed to this directory. And now, if I am in my home directory and I say cd exa, I'm going to go back to this directory I was in. However, as you can see, it now sees it as this path. So if I say pwd, it's going to give me the path as if I was in a directory called exa. So what if I want to create a symbolic link to a file in the same directory as the file? Could I do that? Let's try and do that. And by the way, I'm just going to go back and into this directory directly again, so I know the full path. Here. So now I'm going to create a symbolic link in here, ln minus s, and I'm going to give the full path, and is the path to my home directory, and then we did Linux exercises, and then redirect. So this is a path here. And I now want to do the symbolic link to one of the files here. And I'm going to randomly pick my file.txt. And then I'm going to, again, give the full path. I don't actually have to right now because I'm in that directory, but I'm going to do it anyway. So I am going again to this directory I'm in here. And then I'm going to give it some name. Some file. That is now the name of my symbolic link. And if I do like this here, I can see that some file is indeed created here, and it points to my file.txt in this directory here. What happens if I try to look inside of this file? It has the same content as my file.txt because it simply points to that. So it is the same. Could I create one to a library? Of course, it's done the exact same way. And let's now imagine that I wanted to take this libcoolness.2.0.a and make sure I can find it by my program that looks for libcoolness.a. So I'm going to say ln -s. And then I'm going to create this directory here. Oops, exercises, indirect. You can see that it's a long path to write, so there are reasons why you would want to have a symbolic link for it. So I'm taking a libcoolness.2.a, and then I can just, since I'm now in this directory, I will just create it directly like that. And just like before, I now have a library that appeared to be called libcoolness.a, but which just points to libcoolness2.0.a. So my program now finds the library that it's looking for. So that is one very useful thing to do. What then if the symbolic link is in a different directory? Well, there is no problem here. I mean, maybe your library that you downloaded and installed, it ended up being put into user lib64, but your program looks for it in user lib instead. Well, you just make a symbolic link and put it in that directory. And then when your program goes looking for it in user lib, it finds it, and always. So that is very useful also. So how do I remove a symbolic link? Well, you can unlink it. You can say unlink and some file. And now some file is no longer existing, as you can see here. Or you can just remove this symbolic link. Again, it's gone. So what is the benefit? Well, if you are doing remove instead of unlink, you can remove multiple symlinks at once, for instance, like with files. Otherwise, there's no real difference. It will work either way. do note when you are removing a symlink to a folder, do not include the slash at the end, because then Bash thinks the symbolic link itself is a folder and it will not let you remove it because RM only removes regular files. Otherwise, you would need to add -R or something for the cursor, like you do when you regularly remove a folder. So, in summary, symbolic links are pointers to another file or directory. They are both soft or symbolic links, and they are hard links. They are useful both for ease, you don't have to write a long path, and to avoid renaming or copying files when your program looks for a file with a specific name in a specific place. And you can remove symbolic links with either RM or onlink. So let us continue to the next section.